Hello and welcome. This video was designed to introduce you to the PractiCAD program by MetaLab Inc., a leading provider of CAD/CAM estimating systems for HVAC and mechanical contractors. PractiCAD is an AutoCAD-based 3D BIM software designed to greatly increase the productivity of a contractor's drafting, estimating, or manufacturing departments. Also, using PractiCAD in conjunction with PractiRev or PractiNav, coordination has never been easier. As many of you may know, MetaLab's fabrication system PractiCAM has the most extensive fitting libraries in the world, including rectangular, round, and oval fittings, both single wall and double wall. So obviously there's no shortage of fittings in PractiCAD either. However, if any PractiCAD or PractiCAM user needs a fitting they would like to draw or download with that is not present in our current libraries, then they could submit a fitting request and MetaLab will gladly add the template for free. Currently, between the two systems, there are over 5,000 duct fittings, which have been conveniently placed in a folder system, making it easy to access when you need them. This also applies to auxiliary items, such as air handling units or VAV boxes. Using PractiCAD's simple catalog mechanism, you can quickly create catalogs of your favorite manufacturers, such as Nemestat, Titus, or Price. Creating new entities is easy as clicking a button, naming your fittings, and adjusting the parameters to whatever you'd like. Create rectangular or round dampers from Ruskin, dual VAV boxes or fan units from Train, or virtually any AHU unit you can conceptualize. It is important to mention that all entities can be parametrically edited on the fly before or after you place them on the drawing. Once you have your catalog ready, just grab the icon you assign to it, pick from the drop-down list, and place the entity on the drawing. It's that easy. Here you can see we're placing a VAV box down, and PractiCAD is going to easily snap to the existing duct line. It'll even automatically place the access door for BIM modeling. PractiCAD's extensive cataloging doesn't stop at fittings. Included in the standard PractiCAD package are entire libraries of architectural items including slabs, walls, ceiling grids, lights, and grills. Just like fittings, you can take these parametric models and create catalogs of your favorite manufacturers. On top of that, MetaLab has already pre-inputted most standard steel catalogs including wide flange shapes, H-piles, structural tees, American shapes and channels, and tubular steel. You can even create libraries of parametric bar joists. Here you can see as we run through a standard K-series catalog. Notice that everything is in your control, including the length, seat heights, and delta for adjusting the webbing. This way your model will have a true representation of what you can expect in the field. Drawing with PractiCAD architecturals is easy to do and can really be handy when you're still working with 2D backgrounds. To make things faster, let's utilize the Auto Steal tool. Here you can see we're going to isolate a background drawing. Then we're going to convert these architectural lines to intelligent layout lines, which can be detailed for pipe, duct, or steel beams. In this example, we're going to convert these lines into 3D beams. We simply start by selecting the steel we want from a pre-existing drop-down menu, choose which spot to hold the steel from, the top, bottom, or center, and then choose our start height and end height in case we want our beams to be on a slope. We simply click on each line we want to convert. PractiCAD lets you convert as many lines at once as you like. Once you hit Auto Steal, PractiCAD will convert the 2D background into 3D beams and will even tag it automatically with any tag you desire. And of course, like all entities in PractiCAD, they each work with collision detection and can be visible in AutoCAD, AutoCAD MEP, Revit, or Navisworks. Now that we've covered the vast parametric entities you can create and use, it's time to show you how to draw with these items and why it's so easy to do. On screen, we were looking at a few things that are happening simultaneously. First, you could see we were working with a preset template with custom layers on it. Second, you can see that we are selecting zones and specifications as we go. PractiCAD has the ability to place an entity on a preset layer or create one on the fly for whatever criteria you may choose. In this example, it's specification and zone. It's also important to mention that these specs are imported directly from PractiCAM, so there's a perfect match between systems. Literally everything is automated from duct lengths and connections to tie rods and stiffeners. Following along here, you can see that we're going to build two lines. One is a slip and drive spec in a supply zone, and the other a TDF spec in a return zone. They are automatically being placed on different layers because of specifications and zones. And notice as we move fittings between duct lines, PractiCAD is updating everything as it goes. This makes layer and spec management fully automatic, thus reducing mistakes. With PractiCAD fittings and features, drawing has never been quicker. Look here as we simply grab a fitting and specification and PractiCAD updates everything we need to draw with. See how we can draw piece by piece and just snap to the fitting we want, and it automatically resizes and updates connections. We can also just key in C for continue and the fitting will snap to the last opening we used without having to find a hard to grab node or use an attacher of any type. Duct can be rotated in all axes through the direction wheel or just by circling your mouse. We can draw an entire duct run at once without having to go piece by piece. We can even size the line before or after we draw. Notice here as we click on a fitting that's already on the drawing, change the parameters in the ACAD property box and everything adjusts to accommodate this change, including a transition before the change and adjusting the entire duct line downstream. Each entity knows it's part of a system as a whole, allowing us to mix and match fittings between lines while the software updates everything for us. See here how we pull the fitting away by just one node. Notice the entire duct run goes with it. Then we did it a second time. We updated the size of one line, and then we updated the size and connector of another line. Notice the edits to these individual lines. Even after doing this, if we bring these entities back together, PractiCAD will automatically adjust the sizes and connections to make these fittings part of the duct line again. Now that this duct line is back together, we can again just click on a fitting, update a parameter, and the entire duct line will follow. Looking further into PractiCAD's intelligence, we will focus on this 56-inch TDF joint. Notice the fabrication level says label only. For this user, it means send a coil line. Notice as we change connections, it changes the length to slip and drive coil line joint. Then, if we change the length of the duct, the fabrication level switches to cut and label, which means now send to plasma. Following that, we will change the connections, and you can see it's adjusting connectors of surrounding fittings and also adjusting length. If we bring everything back to what should be a coil line piece, PractiCAD will automatically update it again. By specifying your criteria for what fitting should go to what machine, we can completely automate the download to PractiCAM. So let's cover the workflow for drawing duct again. Choose your specification, select the fitting you would like to use, and snap to the line you want to connect to. Have to change parameters? Just do it on the fly from the parameter box, and you can watch the fitting adjust right in front of you. Whether you're connecting duct, round pipe, or a custom VAV box, each entity is only one click away from placement. Simply put, drafting on PractiCAD is simple and easy. It doesn't matter whether you're working in 2D plan view or isometric views. PractiCAD makes it easy to place an entity wherever you need it. Here you can see how easy it is to draw a riser. Just simply rotate the fitting, place it down on the drawing, and each new fitting is only one click away. It's even easy to run boot taps off the side of the riser. Just attach the boot and use the wheel mouse to scroll the boot into position. Notice how easy it is to avoid the stiffeners here since PractiCAD automatically draws everything in for you. Once the tap is placed, just grab your next fitting and it will automatically snap and resize right to it, making it easy to continue the line. Want to copy a line? Use PractiCAD's Copy Tap feature, where all you have to do is right-click a fitting, choose Copy Tap, and tell PractiCAD where you want it to go. It will automatically copy the entire line over, including duct, tags, flex, and GRDs. Combine this tool with PractiCAD's auto routing feature, and you can connect GRDs to the line in no time. It's easy why to see PractiCAD as the most intelligent objects in the industry. There are several different types of auto routing features in PractiCAD. The first type is a simple feature that allows you to connect any 2 points with a fitting of your choice. No longer do you have to figure out difficult offsets. Just put 2 fittings on the drawing as you see here, and then drag the fitting of choice between 2 points. Let PractiCAD do all the calculations for you. Here you can see as we're using a few different types of transitions, including an extra straight and a double offset OG. In addition to what we call the single route, we can also choose to do multiple fitting routes. For example, maybe we would like to have 2 90-degree elbows equally routed between 2 pieces of duct at 2 different elevations. Perhaps we might want to route several pieces if there's a greater elevation difference between the ducts. We can use it for calculating sizes or turns. In this next route, we are telling PractiCAD to use 45-degree elbows specifically. However, we can choose a large variety of different scenarios to make sure that we get the angle we want. Notice here as we route between 2 points using several different options including 90s, 30s, and 45s. Also using this feature with round duct or pipe, PractiCAD will calculate the roll angles needed to make the connection. This makes it easy to look at different scenarios to see which one would suit you best. Use auto routing in conjunction with PractiEst and you can see which of these scenarios is the most cost effective for your shop. But the routing options don't stop there. We can create damper routes to automate the placement of a damper inside a fire rated wall. Just grab a piece of duct, route through the wall. You can have the damper you want selected, positioned, the wall opening created, and the proper tagging to show your heights and opening size. This can greatly aid you in producing a fast wall opening drawing. And lastly, we have the ability to route GRDs to duct lines extremely fast. This makes sense because often contractors use similar scenarios to route the grills. Build these automatics and simply click between your trunk line and your GRD. PractiCAD can fill in the rest. Notice this routing automatic uses an STOD from a preset catalog that is to be ordered. This way we can report it later. Now we'll do one with spin collars as taps. We simply click the grills we want to use, select the fittings you want to route to, and it auto-fills immediately. Watching this next example use conicals, you can also see that we can window an area and PractiCAD will route to them all at once using the fittings nearest the grill. You can run as many of these at once as needed, and there's truly a lot of scenarios to choose from. In this next example, we're choosing between two choices. The first route's one turn at 90 degrees, the second route uses two turns with 45-degree elbows. If the engineer requires a hard pipe connection or doesn't allow for you to bend flex on the GRD, then simply adjust your route accordingly. Hard pipe options and options that require an elbow, no matter how far the drop, are available. Dropping it down to some GRDs lying under the duct has never been easier. Just window select and route. All the parameters you need are there, including min, max, flex lengths. Here's a route that requires a boot tap first. It runs over a grill's neck, then it stops, end caps the run, and then drops down to connect with a spin collar and flex. Using the auto routing feature can truly save a draftsman a lot of time, and it's great for estimating as well. Using PractiCAD's estimating features, we draw over the PDF. You can see here the job requires conicals, pipe, and flex. We window the area and route as we need. It is well known that tagging and annotating is one of the most time-consuming tasks a draftsman must go through. Many would say it takes almost 50% of a draftsman's time, so it was essential that PractiCAD found a way to automate this. There are two main ways to tag in the system. Through Autotags, which place tags as you route and draw, and Automatics, which, like you were seeing here, can tag any section of a drawing with the touch of a single mouse click. There are several reasons that PractiCAD's tagging mechanism is so efficient, but we will focus on two key points. First, that all tags are extremely intelligent, following an if-then logic dictated by the user, which makes sure each tag shows the proper information how and when the user wants it displayed. To represent this, we're going to draw a PractiCAD slab at 5 foot and mark it in the elevation box. Then we're going to place an elevation tag on one piece of duct, tagging it from the finished floor, and the other piece of duct from the relative slab height. Looking at these two tags here, you can see the elevations are different. Now we're going to edit a piece of duct from the AutoCAD property box. Notice that upon the change, every single tag updates its proper information instantly. Next, we're going to focus on the transition that PractiCAD autofilled to compensate for the change. Notice the depth in and out are equal, and notice there is no top-up-down tag. This is because the user did not want one, there was no change in depth. However, edit the fitting and changes, and you can see it immediately puts the proper top-down tag in place. It is also changing the relative elevations for each tag from its particular reference point, all the way downstream. Notice when we change the top change to 0, it says flat top. When we change the bottom change to 0, it says flat bottom. Shortly after this, we're going to set this line left, and PCAD is representing the greater of the two offsets. Once again, a user-defined choice. The bottom line is, whatever change you make, the tags will automatically edit the way you want. This means no misrepresented text and no need to erase and retag anything again. The second most important part about PractiCAD's advanced auto tagging is positioning. Watch carefully as we auto tag a piece of duct running left to right on the drawing and show the name of the tag in the AutoCAD property box. Then we tag a duct running up at an angle to the drawing. Looking at the property box again, you can see we get two different tags here because of two different orientations. PractiCAD can use virtually any variable, including orientation, to make sure a tag goes exactly where it should, anywhere on the X, Y, or Z axes. Looking at another important variable, we will demonstrate changes in size. Look here at the duct line. Notice each fitting is getting smaller than the next. When the PractiCAD tagging automatic is triggered, it searches the fittings for their sizes and chooses the exact tag we want in the exact place we need. You can see how the W by D tags and the length tags are changing and moving inside and outside of the duct to accommodate for these differences. Even when we decide to run a piece numbering automatic, the software places them neat and cleanly on the drawing exactly where the user wants them. And remember, since we have logic-driven tags, we can do logic-driven numbering as well. For example, notice here as we piece number this supply run up top, the tags show 9S or 10S for supply. But when we number the bottom return line, the numbers show 9R or 10R for return. These will even change as we edit the drawing later. You may also notice the option for identical fittings, identical fitting numbers. Lastly, we have a situation where a user wanted to auto piece number but wanted the border of the numbers to change based on material. Galvanized got a circle border. When we added the material later to aluminum, it got a square border. Then a hexagon for black iron, and lastly they had a circle inside a circle for lying duct. All of this can be automated through our advanced numbering automatics, always making sure you get the right number in the right place. Now that we explained some of the vast options we have for tagging and how they work, let's watch how easy it is to tag and retag, number and renumber, all while editing along the way. First, we're going to highlight the whole system and tag it in just one click. Then we're going to number the duct line from number 1 all the way downstream. We will then highlight an area and use an automatic to just delete the numbers off this one section. Now we're going to choose to renumber this section of duct line starting from number 100. This is just a small sample of how fast we can globally update any section of any drawing anytime. And of course, things can be edited individually and from a lot of different areas in the software. See here as we simply click on a fitting and change a piece number right inside the AutoCAD property box. Now we're going to make a drastic edit of the parameters of this duct line. Notice now that the tags and the piece numbers don't sit where they should. The drawing is no longer neat and clean. We'll just use one automatic to select duct line forward and use another one to retag, and everything is back exactly where it should be. And yes, this video is showing these changes in real time. Finally, we're going to edit things back the way they were. Once again, all happening in a simple mouse click. Watching these tagging automatics at work, it's easy to realize that there is nothing on the market currently that can edit with such speed and such precision as PractiCAD. This feature alone can save hundreds of drafting hours in the course of a year. From tagging your entities with dimensions and elevations, to automatic piece numbering, and wall openings. Think about what PractiCAD's auto tagging can do for you. As many of you may know, PractiCAD comes with a fully integrated report mechanism that allows you to either modify hundreds of preset reports or customize your own from scratch. And we didn't want to lose this capability in PractiCAD. So inside PractiCAD, you're capable of building any report you like, which can be exported to Excel, printed out of Practicam or PDF, or put as schedules on the drawing. Notice here how we hit a reporting automatic and it's conveniently counting everything we have on the drawing and instantly creates the reports we want. You're always just one click away from seeing everything you need to order, like STODs, medium pressure or short adjustable elbows, conicals, or spiral pipe, order boxes of flex, or just have schedules of all required GRDs, VAV boxes, and fire dampers. Literally everything in the system is reportable. No longer do you have to spend time making reports by hand. Watching through the start of this video, you were probably realizing that PractiCAD truly has the best editing in the business, and it's never been simpler. Watch as we just click on a fitting, grab a node, and type in the direction we want to go, taking the fitting and the entire run behind it as well. Then we will auto route a transition to fill. Need to adjust the line again? Just click and change the parameters in the ACAD property box, and everything shifts in one motion. Now we're going to click on the catalog STOD. Looking at the properties here, we can see everything pertaining to positioning is there. We're just going to move it 10 inches down the side of duct. Once again, taking the entire run with it. Notice even the flex is stretching. Following that, we're dragging a node off spiral pipe and keying in the value we want to extend the pipe. This allows us to edit fittings direct from the drawing as well as the property box. Understanding PractiCAD's duct line integrity, we can easily make quick changes to edit exactly the way we need. Here we're going to delete pipe, then click on the elbow and raise the duct line forward to 15 foot. Then we're going to use an auto route tool to route two 45-degree elbows between the points. We can even click on the elbow after the change and change the slope of the line by adjusting the angle. In this next example, we're going to show you how we can edit full duct lines in either direction. Notice the little blue arrow on the transition indicating the direction we're going to try to make a change. First, we're going to edit the duct line forward. Then we're going to do the PCAD parameter box, reverse the airflow direction, and edit the duct line backwards. We can actually isolate fittings off the run to make changes, edit duct line forward, duct line backwards, from one point to another, or even globally edit the entire drawing. This includes updating the specifications. And there's even more options available. See here as we click on this VAV, and when we right-click and select Edit Fitting, PCAD opens up the Edit Fitting window. Here we can view, rotate, or shade a single fitting. By simply rolling your wheel mouse, we can flip the control box to the other side or change any parameter associated with this entity. And then when we break out of this window, you'll see that PractiCAD will make all the changes and update the drawing. And there are editing options for entire sections of duct as well. Using the PCAD partial view window, we can window select an entire area. PractiCAD will then display this in the partial view. Here we can see several fittings or assemblies and select the fittings we want to edit. Once a fitting has been selected, the entire property box opens, allowing us to make changes. Once we are done, we exit out and PCAD updates the rest. This allows us to avoid having to use the AutoCAD isolate command, which has been known to slow up large drawings. Using PractiCAD's editing capabilities, combined with its internal collision detection, BIM modeling has never been easier. We simply see a collision, click on the collision mark, and PractiCAD will tell us how far we need to raise or lower the line. Using this information, we then click on the fitting we want to change and simply adjust accordingly. When the collision is gone, the mark will disappear and you move on to the next one. It's that simple. Though PractiCAD has a huge list of time-saving features, our editing features are one of the customer's favorites. Using these capabilities greatly eases the coordination process while prevents us from having to redraw, retag, or renumber, and it's all under one program, PractiCAD. That being said, however, you can also utilize PractiCAD with other collision detection programs such as Revit or Navisworks. See here as we make changes to PractiCAD on the right and hit refresh to update the Navis model on the left. And with the addition of PractiRev or PractiNav, you can further enhance your BIM experience. Speaking of BIM, we should bring up PractiCAD's automatic hanger mechanism. This system allows us to create various hanger types for both duct and pipe and then specify in our automatics when and where these hangers should apply. This way we get the proper hanger with the proper gauge in the proper place. Once our hanger catalogs are built, we choose which placement options we want, for example, spacing between hangers, and then we choose whether we want to attach the slabs, beams, or bar joists. Once we have our choices selected, we simply click which run we want, and PractiCAD places the hangers down for us. We can do as many runs at once, or we can even do the entire drawing. And just like everything else in PractiCAD, you will notice that our hangers are fully editable, moving and stretching along with changes to our duct systems. Now we will run another hanger automatic for PractiCAD's piping and plumbing package, PractiPipe, but this time we will use clevis hangers from a preset tool code catalog. Once again, we just highlight the lines or systems we want, hit the hanger automatic, and PractiCAD places everything on the line for us. It's also important to mention that these automatics will work for both horizontal pipe or pipe that is going on a slope. As a matter of fact, as you are about to see, even after the hangers have been placed, you can adjust the slope of a piping system in the elevation box, and the hangers are intelligent enough to edit in sync. In addition to what you see here, PractiCAD's reporting can produce bill of materials for all your hangers, and PractiCAD is fully capable of downloading to GPS coordinate systems of both Tremble and Autodesk. This is how coordination is supposed to be done. MetaLab really puts the I in BIM. Now that everything has been coordinated, it's time to fabricate with PractiCAD. Though it's simple and easy to input fittings into our system, a drawing can have hundreds or thousands of fittings on it, all of which need to be inputted into the plasma or coil line. However, using MetaLab's full CAD/CAM estimating suite, we can reduce this labor down to the bare minimum, simply by downloading the ductwork direct from your PractiCAD drawing straight to PractiCAM. Watch here as we use the selection tool to highlight all the duct on a drawing we want to export. Then we press our export automatic, and PractiCAD lists all the fittings we're now sending to the plasma or coil line. Here we can verify the fittings, name the job, and we're one mouse click away from downloading everything. Going back to PractiCAM here, we can see the job was instantly downloaded from manufacturing. And when we download between our systems, we download everything. This includes our vast library of accessories. Stiffeners will come across for reporting. Tie weld holes are burned by the plasma or punched by the coil line. Splitter vanes are automatically cut in radius elbows, including drop cheeks, as well as the holes are burned for tack welding for those that choose this option. Damper blades are cut with everything we need, including U-bolt holes or earless. Even the damper shaft insert holes are burned by plasma. Choose the mount shop option in PractiCAM and the holes for your taps can be automatically cut. With square elbows, we provide the option for cutting out your own vanes or burning the holes for inserting the vane rails you buy. Remember, if any fitting doesn't download from PractiCAD to PractiCAM with the perfect parameters, blank scenarios, or accessory options, MetaLab will create a brand new fitting template in both systems for free. We truly pay attention to every detail. Use the PractiEst option to get estimates of everything you download as well. See material in terms of cost or weight, or labor in terms of cost or time. Now we can compare the actual cost with the drawing from the original bid. So that is going to conclude this short demonstration on PractiCAD, MetaLab's sheet metal drafting solution, and your BIM software of choice. We hope you enjoyed this video and will contact us soon for a full presentation. It's simple yet very automated tools for drafting, tagging and annotating, piece numbering, coordinating, editing, reporting, estimating, and a fully automatic download of Fabrication. One can see why so many users are switching to PractiCAD. Please make sure to also look into other products and services by MetaLab Inc., including PractiPipe, PractiEst, PractiRev, PractiNav, and of course, PractiCAM, the best manufacturing system on the market. A fully integrated solution for all your CAD/CAM estimating needs. Once again, thank you for joining us to watch this demo. We hope to see you soon.